All right, it's recording. So, so thank you all for joining in. We have our mentor slash expert talk for challenge number 16 today. We're looking at video timestamp generator. Let's get right into it, right? So our sponsor has put up a problem statement about to create chapters, a feature, to YouTube videos to make things easier for content creators and viewers. So many of you may already be aware of this feature, but YouTube now allows you to, in the description, put in timestamps of when things are happening. So for example, if you're recording an hour-long lecture, you could break up the lecture into multiple segments by using the timestamp feature. So that's what they're trying to the problem statement they want us to address, and the issues to be addressed here is currently creators are supposed to manually add the chapters on a particular timestamp to each video at the time of uploading. Trust me, I am one of those uploaders who manually type in the timestamps, and it's a painstaking, a very lengthy process. Sometimes you get the timestamp wrong, and all of a sudden the rest of it doesn't work, and you have to go back and fix it. So anyhow, it is now asking the solution that we're expecting from the sponsor, the sponsor is requiring us to find, is implementing machine learning or deep learning to recognize text in the video in order to auto-generate video chapters. So scanning the video or scanning the audio of the video to determine when certain chapters should be pre-shown. So to help us with creating this type of solution, I have an expert here with me, Larry Kiliszewski, and first time saying your last name, so apologies if I butchered it. But Larry, thanks for joining us at TiE Houston here for the TiE Hackathon. We appreciate you sharing your expertise around this. So let's get right into it. If you were given this challenge, how would you tackle it, and what should students in college and university be looking for to hack out a solution for this challenge?
Sure. My background is medical device design, and so I don't have a huge amount of familiarity with coding and stuff, but in our field of work, we're always dealing with problems that are new to us. And so we just follow kind of a systematic process for evaluating the problem, evaluating the requirements, and then putting together basically a plan to move forward on how to solve the problem. So I did put together a few slides that I'm going to show. And you guys should be able to see that.
Yes, we see it.
Okay, so basically everything starts with the requirements, and so my slides here are going to basically walk through how we look at a new project that we're not familiar with, maybe the technology on. We determine what we need to know about the technology, and then we implement some kind of a plan to come up with a solution. So obviously the requirements are the first and most important thing, is to find out what specifically the customer is looking for. And I just grabbed these requirements off the main sheet. There may be more detailed ones in the project, but this kind of just conveys that idea. So I just highlighted the main things, right? A web or desktop application. It does not need to be compatible with all operating systems. And it should determine which sentences in the video are indicative to a new chapter or subject, and then basically find the timestamps and then write them into some chronological order. So what we would do is first we would try to understand the technology. So if the students in this case already understand the technology very well, they may be able to do this quickly. But when we're dealing with projects in our work, every single product we do is never been done before. So for us, we have to constantly look at technologies and understand them before we can start a project. So just some examples of that would be, understanding ways in which sentences are formed, understanding common methods, and defining a change in subject on YouTube, maybe doing some searches on how people prepare YouTube videos. And there's instructionals on how to do YouTube videos. And I'm sure in those searches, you could find instructions on, the ways to create breaks in subjects that are, that keep the user interested, because there's probably some very common things between these breaks and chapters or sentences or subjects between many videos. And then verify against a video with timestamp. So once you've come up with some kind of proof of concept solution, you can take a video that has timestamps and then run your solution against that to verify that it seems to be working, or design your software with an existing video that has timestamps. So just kind of understanding in general, what are you up against, what's out there, how does it work? And there's just a ton of stuff that can be done on Google, of course. There's so much information on the internet. So just going into Google or one of the search engines and typing in things like creating YouTube videos, breaking subjects in your videos, how to find a timestamp, how to code for a timestamp, you could probably find lots of information to help you kind of define how you plan on approaching and solving the problem. And that's really important because you really have two objectives here. Your first objective is to develop some kind of a proof of concept of the idea that you can present to the sponsor and say, look, this small bit of software we've written proves that the idea is possible. But then objective two is really, you want to show them that not only is it possible, but we're capable of bringing it to a final product. So, the proof of concept's great, but if you can't sell them on the belief that you can bring it to the end, then it's not really going to mean much to them. So kind of achieving those objectives, like I said at the beginning, they start with the requirements, right? So we define the product requirements. The way we do it in our device design process is we create a matrix of information. And this is the first part of that matrix. We need to understand what the customer wants. And, I only listed a couple of the requirements here, but there could be dozens and dozens of requirements. So we build those vertically in a table. And then we build that table out with different phases of the project. So in the work we do, and in almost every product we develop, we go through these different steps through the process. We define the requirements, we define the inputs. So our inputs are basically the requirements in technical form, the requirement being an operating system, the input being a Windows operating system, or all video formats, the input being MP4, AVI, whatever video formats are required. Those are basically the two main things you're going to need to do your proof of concept. Everything else is really development beyond the proof of concept, but you also have to know that information to some regard to be able to sell the idea later to the client. So once you've defined those two aspects, you want to define the rest of your process, which is basically get some kind of understanding of what kind of coding you're going to need to use to develop the software, a method by which you're going to verify that your code works and that the process works, and then a method by which you're going to implement that with users to get users to give you feedback. And then you want to put all of that together into some kind of a program, like a plan for the customer. So by the time you're done with the first part, you'll have maybe your proof of concept, but you'll also have a plan and cost to take that proof of concept all the way to the point of delivering it as a consumer product, or in our case, a finished device that can be used in the medical industry. So that's kind of the process that I know that's a ton of information, but that's kind of the process that we work through when we bring in a new project. We take a detailed look at the requirements. We try to define them as inputs as best as possible. And then we'll spend some amount of time in those first two segments of the project creating some kind of proof that the idea could work. In the case of what we do, we build a CAD file and maybe a prototype with some working components, and then we would present that to the client and say, this is kind of the general idea and how we think this is going to work. And it may not be pretty, It may not encompass all of the features that the end product will encompass, but it basically proves feasibility. It proves that the product can be made. It can be made for a cost-effective amount and turn a profit for the customer later, which is what they're going to want. And it gets you far enough along where they have some confidence that they're willing to write the check to finish the project all the way through to the end. So I heard in one of your other videos, you'd asked somebody to share their contact information. So I just want to share it here real quick. It's larry@zuski.com is my email address. And if anybody wants to email or contact me with any questions regarding this process, I'm happy to answer any questions. So, but those are my slides. They're pretty generic, but I'm happy to talk through them.
Well, they were really informative because you gave them the process, listing all the requirements. Here, the sponsor has made a lot of the requirements. So the way you would start is you would start that first vertical requirements list. Just start listing out all the things. Question for you, Larry. Given that the nature of the solution is the unknown, right? There are a lot of unknowns about doing something new. How would you know that the client knows all of the requirements? For example, if people in the early 1900s asked Henry Ford, if Henry Ford asked the people what do they need more, they would have said we need more horses, right? The clients sometimes don't exactly know what they need. So how do you come up with requirements that weren't actually defined by the client, but can help the design process? Any thoughts on that?
Yeah, that's a fantastic question. And that happens all the time, right? In our world, it's mechanical. So if somebody says it has to be sticky, we don't exactly know what sticky means, right? So yeah, I mean, there's a couple components to answering that. The first is, yes, they don't always know, like they'll say what they want in the terms they know how to communicate it, but they don't say what they want in terms that the engineers know how to define it, right? So certainly there's many times we have to go back. I mean, we use, in our process, we use a discovery meeting. So the customer will send us some list of requirements, and then we'll require that the customer sit with us for 2 hours and go through those requirements one at a time so that we're crystal clear on exactly what it is they want. So when they say blue, we say, what shade of blue, or they say sticky, and we say, okay, here's 3 choices of sticky. Which one do you like? And we try to help us define that second input column, right? The second answer, or part of the answer, is during the process of development, we're going to discover all kinds of things usually that we didn't even think of in the beginning, especially on a project that is brand new and has never been done, that we're going to be able to go back to the customer on then and say, hey, as we were developing this, we discovered that we can do this as well. Would you like to add that to the list of requirements? Or maybe in some cases we find a hurdle that we can't get over, or that will require a larger amount of funds to get over, and we have to go back to them and say, would you like to remove this as a requirement? But you're absolutely right. The customers, they know what they have in their head, but they don't always know how to put it on paper. And it's definitely an interactive process with them to really figure it out. And that's one of the reasons why it's so important to understand the technology before you begin this process, because if they don't know and you don't understand the technology, you're not going to know to ask the questions or to get more clarification.
Good point. And so during this hackathon, there will be an opportunity for our students to talk directly to the mentors, to the sponsors. So that is certainly being offered to them. In addition to the requirements, now looking at the design process, if we are talking about the inputs, the outputs, the verification, the validation, I think you had, where does the process, like the actual, I think of inputs and outputs as a process in the middle, right?
Yeah.
Did I miss it, or was it there just shown differently?
Yeah, no, you didn't miss it because it wasn't there. I actually had some additional slides, but I didn't know how long it would take to present. So in that process of requirements, inputs, outputs, verification, validation, we break the project up into phases. And in our case, we use 4 phases, and then we have like a discovery phase where we're figuring out all the information at the beginning. So that's the process we follow. Is basically we do a discovery process where we learn about the technology, we talk with the customer, we figure out what it is they want exactly. Then we do our first phase where we basically try to define in technical terms what the requirements are. And at that point is when we start figuring out what tools we need to do that, like what kind of programs or computers or software we're going to have access to accomplish that objective, right? And start piecing together the ideas. Our second phase is our feasibility phases, where we basically build our first proof of concept and we define whether or not the product can be made and still make the customer money. Because lots of things can be made, but they can't be profitable, right? So that's the second phase. The third phase is really development. That's the output process where we start actually producing, past the proof of concept, production level work, right? CAD files and injection molds and things like that. In this case, I guess more refined coding for different types of video files, more refined coding for different types of operating system platforms, things like that. And then the last 2 parts are really outputs and verification kind of take place in the same phase, but verification, which is cross-checking your tests or your work, and then validation where the customer can come in and basically look for problems. So it's like too many development programs though. I mean, the first 2 phases are really building your proof of concept for the customer so that you can sell them that the project is a feasible project. And then the last 2 phases are really designing it for production or designing it for the consumer. I'm not sure if that answered the question the way you're asking, but.
No, it gave me some clarity because, so look, your students are going to be taking part in this hackathon. At this stage, what you're focusing on is the feasibility part, right? Where we're not yet creating the consumer design product. To satisfy the needs of our sponsors, we are now trying to put together, some prototypes that can scan the videos or scan the audios of the videos to be able to automatically determine. So as an example, maybe you ignore the video and you allow the customer to upload the video, but you only look at the audio. Every time there's a gap in the audio, you put a marker automatically using machine learning or even just, whenever the audio is dead, tag it and make an output file, a text file that says at 00, there was audio, there was no audio. At 0, at 1 minute into the video, there was another pause. Maybe every time you have a pause, maybe that's what you showcase. Now, if you've got the skills to actually run that through open source applications or tools, then go ahead and design the prototype. If you don't have the skills to do that in 48 hours, then make the idea proposal that this is how you would tackle it. You can use paragraphs to explain the process. And I think what Larry has done really well here is defining inputs and outputs and how would you verify and validate that what you're thinking is going to work. Maybe go show another example. So I like how the design process, defining the design process, how you could conceptually think it through. And even if you don't actually go and build that design because you don't have a team member who can do video scanning and all those, they may not have those skill sets, then don't have to worry about the prototype. Just get the product solution to show that it's feasible what the customer's requirements are. And if the customer at that point agrees that, hey, this sounds good, this is worth testing, then that's where the summer internship comes in. Larry, I don't know if you're aware, but our sponsors are not only making $15,000 of cash available for the best ideas, but also summer internships for students that are solving their challenge. So some of them may actually get an opportunity to go design it, because these things does require some skills, and some students already have them, some don't. But the internship is the opportunity to now go act on them and get skills and do. Larry, one more question before we wrap this up. I've asked everybody, every expert, is where do they see, you see this example here in this hackathon, an actual sponsor putting their real business requirements, and then a bunch of students are taking a crack at it. Where do you see the future of hackathons? Is it, do you believe it's in the interest of the student to participate? Do you, or not? Where do you see this type of solution, crowdsourcing of solutions? Let me put it that way. Where do you think that would be in the next year or two from now in the US?
Yeah, absolutely. So let me go back to one other comment on something else you just said, and then I'll answer that question, which is you're absolutely right about in the short time frame, many times you can't build a proof of concept, but you still have to convince the sponsor that you're capable of building the proof of concept, right? And so definitely that is another step that could be in between the two, in that you just write out your plan to get to that phase 2 step, or that feasibility point. And that, of course, in our business, we have to do that as well, right? We're not always given $50,000 to go build a proof of concept. Sometimes they're like, can you do it and prove it? And so we have to build out a whole project plan before we even start a proof of concept and sell that. To go back to your other comment, I mean, these are fantastic opportunities for students. Just a little personal background. I'm actually not an engineer, like per se, like a mechanical engineer. I'm a product engineer. I worked as a draftsman and then a designer for many years. Eventually I started my own engineering business. Now we have 11 employees, 7 engineers that work for us. We do 90% medical device design. But I just did it all by not closing any door to opportunity, right? Just like everybody that would teach me, I would listen and try to learn and try to apply what I learned. And so the opportunity for students to have access to people, really, no matter their educational background or their professional background, if they have expertise in some area and they're willing to share that expertise, it's a fantastic opportunity for anybody. And the student always has the opportunity to say, that's not useful to me right now, but I'm going to use this instead, or pick and choose what they want. I mean, you can't do everything, right? There's going to be a bunch of these videos out, and they're going to have to pick the ones that they connect with. But I love these opportunities. I think they're fantastic. And I mean, even at 53, I just attended something similar to this to benefit me yesterday at the University of Wisconsin, right? So, I mean, we never stop learning. There's always opportunities to learn from. So I think it's fantastic.
Larry, I love that. Never stop learning. And you see that this is working. So we just need to continue. So we need to encourage our students to tell their friends and tell others to take part in these, because it teaches you a skill. It gives you the ability to showcase your skills to others. And then, as Larry said, you never stop learning. It teaches you something that you can use, apply apply today or tomorrow. You don't know. The good thing about education is when you invest in your own education, no one can take that away from you. So well said about never stop learning. I like that, Larry. So Larry, I want to thank you from TiE Houston and and Pumps and Pipes, the group that's brought you here for this session. We will definitely share this video with our students who are taking part this weekend, and hopefully they can utilize the matrix that you shared with them. I'm already visualizing, the product requirements, design process at the top. Thanks for sharing that model. I think we definitely want that structure to be used more often. So students, go back in the video, take a look at that again, and take a screenshot of it and try to fill out the boxes the way Larry had for this project. And again, if you cannot submit the prototype, submit the persuasive pitch to making the prototype work, and submit that by Sunday midnight. All submissions are due by midnight this Sunday. So thank you, Larry, and we appreciate your time once again. If you don't mind, the contact slide. Let's put the contact slide as the end there.
Oh, sure.
So you're welcoming students to email you.
Yeah,
Is that
absolutely.
okay?
And actually, if I can share one other
Sure.
thing, hold on one sec.
And I'm
Hold on a
guessing
sec,
people
sorry.
can find you on LinkedIn as well, huh?
Yeah, on our website, we actually have this page under services where they can click and they can see the processes and the steps that we follow. I mean, that may be useful for them if they want to go there. We're making some updates to it, but generally it's pretty accurate. So
No, that's great. Thanks for sharing that. And was it basically your last name.com? I didn't catch the URL.
yeah, it's the last part of my last name. It's just zewski.com.
zewski.com.
ZewskiCorp.com.
Gotcha. Okay, well, Larry, thank you so much. And folks, reach out to Larry if you've got questions. Please do include TiE Houston in the subject, so Larry could identify you as part of the hackathon, and make sure to make your submissions before Sunday midnight tonight, this weekend. Very important. So, all right, Larry, thank you.
Thank you.
Appreciate your time, and appreciate Pumps and Pipes for organizing. So Larry Kiliszewski.
Right.
Kiliszewski. Thank you so much, sir. Have a great day.
Okay, bye-bye.